Hey everybody, welcome back to the next part in our web scraping tutorial in our Python for Daily Fantasy Sports web series. Today, we're going to be going a little bit more in depth with a Selenium package, using the NBA.com stat tables as a real world example for how to navigate, interact with, and pull data from different web pages. Now, if you haven't watched part 1 of the Selenium series, you're definitely going to want to check that out. I'll put a little teaser card up in the top right hand corner of the video, because there's a few steps that go into getting your machine ready to go for Selenium. That's a little more complex than just installing the Python package. Let's get to coding. All right, so just like when we went through Beautiful Soup, the very first thing we're going to need to do is to import all of the modules that we plan on using. Now, if you watched the previous Selenium video, you may recall that we did from Selenium import and then imported a specific module to make our code look a little bit cleaner and be more efficient. So we're going to do that again. So from Selenium, import WebDriver is going to be the first one. Then from Selenium dot WebDriver dot support dot UI, we're going to import select, and that's with a capital S, and that's going to allow us to select, as the name implies, different aspects of the page, aka click on. That's what select is going to be. We're gonna need Beautiful Soup. And we're gonna need pandas. Now there's a couple other things I typically do using Selenium. You can tell the remote driver to wait a certain number of seconds before checking for something to give the page time to load, so you're not constantly erroring out saying it can't find things. And wait, you can establish expected conditions, and the code will not progress until those expected conditions are met. That's a little bit more complex, and for the purpose of this tutorial, where we're going through cell by cell in Jupyter Notebooks, it's not that relevant. But again, if that's something you guys are interested in, let me know down in the comments, and I can make a more in-depth video on how to set those types of parameters up, and we can look into it further there. But for this video, we're going to keep it simple. And of course, Beautiful Soup is one word. All right. First thing here, we need to establish that we're using Firefox as our WebDriver. WebDriver.firefox. I think those are both capitalized. Nope, just the first half. So that's establishing that driver is going to be our Firefox remote browser there. So if we want, we can go ahead and run that, and we should have a Firefox instance pop up down here. There we go. So we have our driver. Now we need to establish the URL that we want to point it to. So we are going to go ahead and go to nba.com, and we want NBA stats. And let's see, we don't want, let's see all player stats. You can go through and you can get all sorts of different stats here, whether you want leaders, whether you want the general stats. We have our traditional stats here. We can do our advanced stats. We can do all kinds of things. We're going to go ahead and use just the general advanced stats here, because I assume if you are wanting to continue through with this type of web series, you're interested in maybe some machine learning and using advanced statistics to create predictive algorithms for how different players will perform in different scenarios. So we're going to go with the advanced stats here. So we have our URL. So we're just going to copy, and then we're going to make that a raw string because there's some escape characters in there we don't want to deal with. Okay. And then we want our driver. Driver.get URL. And now let's put this side by side with our Firefox window there, and see we come right to this web page. Now, a couple things to notice here, and we're going to go back to our website that we had up instead of the Firefox one, because I don't want to mess with that. Couple things. you've got a bunch of different things up here you can interact with that cannot be handled in Beautiful Soup. You can change the table you're looking at. Also notice there's 524 total rows here, and we're only looking at page 1 of 11. So we're only getting, is that probably 50 rows or so on one page? All right, that's not good enough. We need all of them. But if you look at our URL up here, we change it to all, the URL doesn't change. So that means we wouldn't be able to handle this within Beautiful Soup. We have to come up with some way of getting to this web page, coming to it, clicking on this drop down, and changing it to all. Or if that's too big of a table, we'd need to be able to iterate through each one of these pages and pull down the information off of it. None of that can be done with Beautiful Soup on its own. So we've established what we need to do. We need to identify this element, and we need to figure out how to change it on our web page. So let's come back over here to our code. We had driver.getURL. Let's go ahead and that should be fine. So I'm going to establish a select variable. And as you can see, I'm using select with a capital S. We're using select module from the WebDriver support UI package. So that's how you can kind of clean that up. So I don't have to type in this whole thing and move the select back after UI. I can just type select with a capital S, and that's going to let Python know what I'm trying to do. So I want to select, and then I need to pick that little drop down button. So I need to dot select driver dot, and then remember in our first video we did find element by name. This time I'm going to find element by Xpath. That is my preferred method. Oh, didn't mean to hit enter there. To put a quotation. So we're going to have a raw string here, and I need to find the XPath of this right here. So I'm going to simply right click, inspect. All right, so this is what it brings me right to. Select class, stats table pagination, or what page you're on in the stats table, which is what we want. And if we highlight here, you can see it's making that box turn green on the web page. So we need to select that. So let's copy. So we right click that description there, copy full XPath, and we're going to come back to our code and just paste it in. And I'm going to zoom out a little bit so you can see, because that gets pretty big. So we just paste it, close off that string, make sure our parentheses are both closed. All right. So we've established that that is what the select variable is. Now I'm not doing anything here. I'm just saying that I'm declaring this variable select to mean if I call select again with a lowercase s, that means I'm uppercase selecting that element on the page. So if you look back at our Firefox window here, the drop down's not there. I haven't selected anything. If I were to just run select, it's going to just run me back, the WebDriver support select that. So I need to be able to call it with something. So if we look at this, this is going to give us a list of the different options we can choose. And if you noticed, all is the first option. And if we go back to inspecting the element there, here, let me do it on Chrome so it's a little bit bigger. So if we go back and we look at this, our first option is all, and the cat wants to join the video today because she is the most important thing in no matter what's happening in the world. So we can see all is the first option over here. All is the first option in the dropdown when we open it up. And if you remember from, I believe it was our Beautiful Soup videos, I mentioned that Python indexes start at 0. So the first option is going to be 0. The second option is going to be 1. So if we want to select all, we need to select the 0th index in that list. Let's make this a little bigger now while I type it out. So that's going to be select by index. We're going to do 0. All right, so what that's doing is I'm calling my select, and then we're select by index, just like we did find element by Xpath. We're doing select by index. Now let's pull up our Firefox window that's being remote controlled, and let's see if it does what we want it to do. So we run it, and it should, and there, sure enough, now it's changed it to all. So now if we scroll down, we should have all 523, however many there were, 518. There's 1, 2, 3, 4, 5, 6. So yeah, about 523, 524 total records in this table. So now that we have all of the records in one table, now we can switch over to Beautiful Soup, and we can start bringing that table down into pandas. So this is going to start to look very familiar, or it should at least, because this is basically what we did in the Beautiful Soup video. So if you haven't seen the Beautiful Soup videos I've made, or you aren't familiar with it from another education source, then definitely go check those out. I'll throw a teaser card up in the top right. It's a quick overview, kind of like this is with Selenium, going over the basics. Basically what we need to do is we need to establish the page source for Beautiful Soup to look at. So that's going to be taking all of that HTML with all of those records live on the table and pulling it down. We need to define a parser, Beautiful Soup, and we're going to look at that source, that page source that we just defined, and we're going to use the LXML parser again. We need to define the table. So now we're going to parse through that page, and we need to find that table. So let's take another look at the table. So we inspected element on our drop-down menu here to get the labels that we needed. Now let's take a look and inspect the element, and we don't need that. So let's just inspect element here. Let's see, that didn't give us anything. We just do inside the table, inspect. Okay, there we go. And an easy way to do that, if you're not sure where the table begins and ends on the page, just click one of the data values inside the table, and then you can just start closing up these little arrows over here, and then you can get back up to your div, the class equals NBA stat table overflow. And as you can see, we have NBA stat table, but then within that we have the NBA stat table overflow. And you can kind of tell here that it's not going to be a problem. But I typically go with the most interior or most specific option I can to get started. That way, if there's multiple, maybe there was another class NBA stat table that occurred further down, right? I would want to make sure I'm being as specific as possible, because if you click, both of these are covering the stat table there. But then we have the NBA stat table overflow as well. So I like to stick with as specific as possible. So I'm going to go with the NBA stat table overflow. And we have our table head, table body. So it's going to be very similar to what we did with our Beautiful Soup. We're going to get the class NBA stat table overflow. So let's pull that back up. Parser.find. We want to find the div with attributes equal to this. And when you put attributes in, it's going to be in a dictionary. So we want the key to be the type of attribute and the value to be what we're looking for. So if I know there's multiple NBA stat table overflow classes, then I would need to specify something in addition to that. So maybe NBA stat table overflow, and then the next key is data fixed, values 2, and then so on and so forth, to be as specific as you can. It just so happens for this one, we don't need to. We can just do stat table overflow, and that's 2 underscores there. And then we can close off our dictionary, and then we can close off our parentheses. And so that's going to find that table. And then I'm just going to declare an empty list here for our list of rows, which I actually don't need, just kidding. So we close off our dictionary, we close off our parentheses, and then I'm going to find my headers, table.findAll, th, and then header list equals h.text.strip. And basically what I'm doing is I found all of the table headers here, and I want to, let's see, so I want to pull out the text value, and I want to strip away any leading blank space, any following blank space, any new line characters, anything like that that could be hiding in this. I don't want. I just want the text values right here, which is going to make some of these with the percentage signs look a little goofy, but we can handle that. We know what data we're pulling from. We know what it looks like. That doesn't matter for right now, at least. So we want the h.text.strip for h in headers, and we don't want the first header. So just like in our basketball reference example, the first column was the rank. This one, it's not showing it to you here because it's just sorting by whatever you do, but there's a hidden value there that's the rank that it's sorting on for each of these categories. And we don't want that, and we'll see in just a minute what else we need to do because it's a little more widespread than that. But for right now, that's going to be fine. So if we run that, let's go ahead and make this bigger for now. Let's go ahead and take a look at that header list and see what we have. Okay. So we start with player team, we go down, we've got all of our thing. Like I said, some of those are going to be a little different with the slashes because that's an escape character, so it's got to be coded a little differently to come through in the text. But wait a minute. Look, we have all these ranks here that we don't want because all those are hidden fields that are going to define how those tables get sorted based on whichever field you choose to sort it on. So we need to update this a little bit. Equals header list. Header list equals A for A in header list. So what we're going to do is we're creating a new list here. And we're assigning here. Let's compare it. So we'll do header list 1 so we can compare them. So A for A in header list. If not rank in A. So remember when I talked about list comprehension before, that reading it this way can be a little confusing, but let's start from the back. So our first one, if not rank in A. So if that string rank, all caps, is not in that string, okay, then we're going to add it. So for A in header list, okay, so now read it backwards again. If rank is not in A, then for A in header list, we want to add A to header list 1. Another way to write that would be this. For A in header list, if not rank in A, header list 1 dot append A. So that would be the long way of writing that. So we loop through for every value, so we can do for header and header list if that makes it easier to understand instead of an abstract just A. So for header in header list, if not rank in header, header list 1 dot append header. So for, we're looping with a for loop here. For every value in header list, we're going to look. So we're going to look at player. If rank is not in header, rank's not in player. Okay, so we continue on. Header list 1 dot append. So we're adding player to header list 1. Do the same thing for team. We're going to keep doing that and keep adding all of these until we get to games played rank. And then we're going to see, well, rank is in header. So we just skip this part altogether, move on to the next one. Which it just so happens all these are at the end, so if you were so inclined, you could just cut off at the end But that's not always going to be the case. So I typically like to find one commonality of all the things I'm removing and just cut them all off at once that way. So let's do a little comparison here and make sure they're the same. Header list 2 equals an empty list. And we're just going to do header list 2.append. So we're going to do it twice. One for header list 1, one for header list 2, and they should be the same. So let's look at header list. First off, the normal header list has all the ranks. Okay. Header list 1 does not have the ranks. Header list 2 also does not have the ranks. All right, so let's just do a quick check to make sure that header list 1 and 2 are the same to verify that this is the exact same calculation. So header list check equals A for A in header list 2, if not A in header list 1. So basically what we're going to do is if A is not in header list 2, we're going to put it in header list check if it's in header list 1. So basically anything that's in one and not the other is going to go into header list check. And let's just do that real quick. And it's empty. So there is nothing that is in one and not the other. So we can feel good about that. So I'm just going to, let's see if I remember my hotkeys. I don't. So let's just comment that out. So header list 1, we have, and that's what we want. And normally I would just reassign that to header list so I don't have multiple string or multiple lists floating around similarly named. But for the case of this, we'll leave it separately so you can tell it's a separate entity. So now that we have our headers, again, here we go. Now you may notice here, and I'll show you in a minute what will happen if we don't catch this, because several times I've gone through this and not caught it before. So let's take a look at our stat table here. Make sure we're seeing everything. Okay, so we can see here, we have player team age going all the way down, ending with true shooting percentage, usage percentage, pace, and pi. All right. If you notice in our headers, we go past pi. Field goals made, attempted, field goals made per game, attempted per game, and field goal percentage. So what that tells me is that there are some hidden columns here that I'm not seeing right now. But I don't have data for it. So that's going to be a problem going forward. For right now, just kind of keep in mind that that happened. And we'll deal with how to address that in just a moment, because I want to make sure we can get all of the data out of the table as well. So next we need to establish what the rows of the table are. I just usually do a quick easy variable for rows equals table. And remember, I've already established the table variable here. Table.findAll, except now instead of finding the headers, I want to find the rows. Okay. Except I don't want the first row, because the first row is going to be the header. So let's just take a look here. If I just find the first rows, let's see what that gives us. Yeah, so that's going to be the actual header, which I don't want. So just like we did in our beautiful soup example with basketball reference, we're going to take the first row out and start here, or the 0th row out and start with row 1, because I just want the data underneath here. I've already pulled the columns out. Now rows equals table.findAll. Okay, and then so now let's take a look at that real quick just so you can see. Okay, so as you can see, that's a little bit gross, but that is all of the data here. If we were to inspect element and look at the HTML, that's what we'd see. So we need to clean that up. So I'm going to do player stats equals, and this is going to be another list comprehension, td.getText.strip. So if we come back over to here and we're looking at our data in the HTML, each of these cells of data is a TD. I don't know why it's not TC, because I think of that as a cell, and TH, table header, TR, table row, TD, table D. So I have no idea what the D stands for. Table data probably would be my best guess. So each of these is going to be the actual cells going across that row. So that's why we're finding all TD. And I want to get the text from there, because I don't want, again, just like the headers, I don't want any trailing or leading characters or new line symbols, nothing like that. I just want the text from that cell. So I'm going to get text strip for TD and rows I dot find all TD 1. So close that one and that one for I in range len rows. And then make sure we're all closed out. Okay. Now let's run that. It runs. So let's take a look at that zoomed out a little bit so we can see. And this may be a little hard to read, but I want to be able to see it on one screen. So let's just make it full screen so we can see it a little bigger. Yeah. Okay. So player stats. Let's take a look at this again from the back. So for I in range length rows. So to give you an idea of what that is, rows is every row in the table. Length rows 524. So there's 524 rows in this table. So that's what length rows is. So that's for I in range. We could have put for I in range 524. Would have been the same thing. But typically you don't want to spend the time to find exactly how long it is beforehand. You just want to be able to automate it so it does it on its own. So basically for 1 through 524, we are getting the digit, the table data, and every single value going across the column, because that's what this is here. So for every row, so row 1, row 2, up to 524, we're finding all of the table data for that row. Again, skipping the first one because we don't care about the rank. And then for each of those that we find, we are doing a get text and strip for it. So that is what that layer or that list is compiling. And then if we look at it, we have everything going across that table. Dylan Brooks, Memphis, 24 years old, 68 games played, 32, 36. We have all of this data here. Now let's double check, and we should end on 5.9 for his record. We sure do, 5.9. So that means that we do in fact have hidden values. So let's just look at one record first. So Dylan Brooks. So we end at pi, 5.9, then 103.39, 24.4, etc. You can tell we're not going past pi. So we have verified that those are hidden columns that we're getting past pi for the field goals made when we looked at the header list. So if we didn't catch that, and we just tried to dump this into a data frame, dd.dataframe, player stats, columns equals header list 1. So if we just try to dump this in, we're going to get an error that says 27 columns past data has 22 columns. So what that's saying is our columns variable is giving us 27 columns, but the data we're passing only consists of 22. So that means we have 5 extra columns somewhere. Let's take a look. Header list 1. You can see, all right, 1, 2, 3, 4, 5. Yep. And we're fortunate here, all 5 of them are at the end. So we can just chop up the last 5 values. If they were dispersed throughout, unfortunately, you'd kind of have to just go through it and figure it out. I'm sure there's a better way to do it. But at the level we're looking at here, the easiest way is just to pull them out. If you're pulling straight out of a table, you can be pretty sure that what you see is going to come in this order. So we're just going to do header list 1 equals header list 1, starting at the beginning, taking off basically the last 5 values. So we're going to end 5 values before the end. So if we run that, and we can run header list 1 again, and we can see now that we end at pi because we chopped those values off the end. So now we should be able to rerun this since we just kept header list 1 as the variable name and just reassigned it. We should be able to just run that with no error. And now we can come back and run stats again. And now we have our data frame of advanced stats. Let's take a look here. 524 rows, 22 columns. We have our generated index here creating it. So again, we have all of our data here. And then we can sort, we can group by, we can do all sorts of stuff here. If you want to take it out to Excel to look at it, data frame dot to Excel. What did I name it? Stats? Stats. And let's just put it. Oh, where do I have everything saved at on this computer? We'll just put it in FanDuel. Alright, so we'll just put this. Also, I don't need that. In the R, I am a mess. There we go. So, we'll put it in this folder, and we'll name it advanced stats example.slsx. We run that. And now we can pull in to that file location, open it up in Excel, and there you go. And you got all these green dots because they're coming through as text when they should be in numbers, so you can just bulk update that. And obviously not all of this is ready to go into a model by any means, but this gives us an easy way to extract that data on a big picture and allows us to sort and compare and visualize if we want, however we want to do it. So that's going to do it for our Selenium example. Coming up next, we're going to be looking a little bit more into pandas and actually handling all of this data that we've got. Now that you've got a strong framework for data gathering, data collection, web scraping, I'm pretty confident that coupled with the documentation of what I've shown you, you'd be able to go to virtually any data repository and get what you want. If you're having trouble with anything specifically, be it a certain website or a certain function that's just not working the way it looked like it worked in one of my videos, feel free to let me know down in the comments, and I am more than happy to take a look at it and possibly make a video going over that specific issue if it's going to be beneficial enough for everybody. So thanks again, everyone. If you want to stay up to date, go ahead and subscribe, hit that notification bell, and I will see you guys in the next one.